Factoring ax squared plus bx plus c. First, we must multiply the values of a and the values of c. In the example we're going to be using, we will be multiplying the 2 and the 10, as you can see, and get 20. Next, we must find the factors of AC. In this case, it would be 20 times 1, 10 times 2, and 4 times 5. Now we must select the option that adds up to B. In our case, B was 12, so the only option that works is 10 times 2. Then, we choose a pair, and we plug in both factors as a sum of EX and DX to get from that to that. In this case will be 2x and 10x. Then we apply the associative property to associate two terms, 2x squared plus 2x, to get that. Then we use the inverse distributive property to factor out the greatest common factor. So, to get from ax squared plus dx plus ex plus c, in this case it will be that, to whatever we can get here that we factor out. In this case we can factor out the 2x from the first term and the 10 from the first term. You'll notice the x plus 1 is repeated, and so we arrange the remaining values, which is 2x and 10, in a second parentheses, and obtain the factors. We must also check our answer using the FOIL method. And so we get what we wanted.
On to our next problem. 10x squared plus 21x minus 10. So we bring it down again to 10x squared plus x plus x minus 10. Now we know again we're going to have to multiply the first and last numbers, so 10 times negative 10 is negative 100. We know one of the factors has to be negative to make it negative 100. However, it's better to wait till you've got them all down to make one of them negative, because once you've seen all the numbers, you can start deciding which one would add up to 21. So you put all the factors: 1 and 100, 2 and 50, 4 and 25, 5 and 20, and 10 and 10. And up to now, there's no factor that seems to work, unless you remember there has to be one negative, so you can make it negative 4 and 25, which, if you add them up, makes 21x. So you can group them together to 10x squared minus 4x plus 25x minus 10. And then you can distribute out the negative or the positive. I'll decide to keep it positive, but if there's ever a case in which it doesn't work out, try distributing the negative one. But for now, we'll keep it positive. So we distribute out the 2x for the first one. So we get 2x times 5x minus 2. Then the next one can distribute out the 5, plus 5 times 5x minus 2. Then you notice that 5x minus 2 repeats itself, so we can group those together, and we get 5x minus 2 times 2x plus 5. And that's your answer.
Now there is another way to get to the answer. In this case it will be 2x squared plus 7x plus 6. And our final answer would have been 2x plus 3 times x plus 2. In this case, we are going to be representing the answer in a square or rectangular form. As you can see, there are different values that we can multiply and get. The 2x plus 3 in this case is represented by the 2 x's, 2 units of x, and 3 units of 1. Then the x plus 2 is represented by 1 unit of x times 1 and 2 units of 1 times 1. Multiply x times x, we get x squared. And if we multiply x times 1, we will get 1 unit of x times 1. And if we multiply 1 times 1, we will get 1 unit of 1 times 1. As you can see here, our answer, which was 2x squared, is represented here by 2x squared. Then we see 7 units of x, and we see 6 units of 6. In this representation, we can only get a square or rectangular form to know that we have got our answer right. This graphic representation works in a similar manner as a times tables chart. In times tables chart, you will see 3 next to its factors, which are 3 and 1, arranged in a way in where they meet. You see 3, which is the answer. Same way as in this one, where the two values meet, you see the final result. To use this representation for other problems, you must take the known values of the original trinomial and represent them as x squared, x, or 1 units in their specific amounts. After you arrange them in the shape of a rectangle, you will know what the two binomials, or factors, are by using the cross-reference system used in times tables chart.
On to our next one. 10x squared minus 9x plus 6. Again, we bring it down. 10x squared plus x plus x plus 6. Now this time it's a negative 9x. So we know that the factors, they both have to be negative. Since 6 times 10 gives you a positive number, the only way to get a negative sum and a positive multiplication would be for both of the factors to be negative. So we bring, all the factors down. 160, 230, 320, 4, 15, 5, 12, and 6, 10. Then we make them all negative, since using logic it has to be negative. We look through them all and see if any of them added up can bring you to negative 9. And as you can see, none of them do. Which is not a problem, doesn't mean you did anything wrong, it simply means that it's a prime equation and you can move on.
Now we'll be using another graphic representation. This time we'll be using 3x squared plus 5x plus 2. Here we have arranged units in a rectangle. We know we'll need an x times 1 unit there, there, and there. And a 1 unit